Hey guys, welcome. This is our 3.4 video, parallel and perpendicular lines. So today we're going to relate the two, parallel, never meeting in the same plane, and perpendicular, meeting at a 90-degree angle in the same plane. So let's get started. So make sure you write that heading up there, make it look real nice and pretty like. Okay. Let's be very clear about something. I've noticed some of you guys are not doing what I'm asking. When I say write all of this, I would like you to actually write everything there. The theorem, what it says, the if, the then. Again, these are all written as conditional statements, which we become masters of. So if something happens, then this would be the resulting factor. Hypothesis, conclusion. Okay? So here's our theorem. And we're going to talk about some relationships between parallel and between perpendicular. Okay, so if two lines are parallel to the same line, so A is parallel to B, and notice these little pieces show that A and B are parallel. Then they're parallel to each other. So A and B are parallel, and B, notice B is parallel to C. So what I can conclude is that line A is parallel to line C. So this theorem is actually much like transitive property for parallel lines. So really this theorem comes from a given property we already established. And again, a theorem is something we can actually prove and show a proof for, which you can find the proof for it in the book if you want to look at it. And it utilizes transitive property to help us establish that. Okay? And let's clear and move on to our next piece. Alright, so write all of this one down as well. Okay, and if I were you, maybe start making flashcards for these. Okay? If you want to make flashcards, that might be a better way that you can go ahead and practice these and know what you need to know. Okay, so I know we did a vocab sheet, but this would be ideal as well. Okay, so theorem 3.9, we don't need to remember the name 3.9, that's just how they name it in the book, but here it is. In a plane, so we have to be on the same flat surface. I think of my room again, like the floor is one plane, the ceiling is another plane, so this could be on the maybe floor. If two lines are perpendicular to the same line, then they're parallel to each other. So M and T, so this is how we denote perpendicular. It's like an upside down T. Cha-cha. And basically, we can show that M and T are perpendicular, N and T are perpendicular, then M is parallel to N. Again, we can prove this. Take a look. These two angles right here are congruent and they're corresponding angles. According to lesson 3.3, if corresponding angles are congruent, then we have parallel lines. And that's what the proof would show. Okay? Let's go ahead and clear. Move on to our next one. Our last one. In a plane, again, we're using, it has to be within a plane, it can't be in two separate planes. If a line is perpendicular to one of the two parallel lines, then it is perpendicular to the other. So this is kind of like a reversal of the other one. We would know if this is 90 and these are parallel, this would also have to be 90 because corresponding angles. And so that's how we could prove this to be true. Again, we could walk through a proof. Okay? Alright, let's look into some examples. Okay, so here's our first problem. It's a proof. Make sure you write out the given, the proof, and the picture. So let's take a look at what we got. Think before we act. And here it says, in a plane, so we're in a plane, this is good. C is perpendicular to B. Okay, C perpendicular to B, so we got that 90 in there. B is perpendicular to D, got the 90, and D is perpendicular to A. Can we show that C is perpendicular to A? Okay. Well, we should be able to do this, so let's go ahead. I'm just going to write S for statements here, R for reason over here. I'm just going to set up the table real quick. Alright, now let's think before we act. I know these are perpendicular, I know these are perpendicular. Okay, well, if these two are perpendicular to each other, and these are two perpendicular to each other, then these must be perpendicular to one another. And again, we can go back and use some of the theorems that we just learned. Okay, so let's first establish what we have, and that is step one, everyone's favorite. C is perpendicular to B, B is perpendicular to D, and D is perpendicular to A, and Y, given. Okay, so we've already established almost everything that we need for this to come to fruition. Let's just for a second cycle back to some of the theorems that we have. Okay, so I'm gonna pull them up in 1 second. Okay, I have the book here. You can just look back at your notes, but it was easier for me to grab the book. But here it says we have the perpendicular transversal theorem, and the perpendicular transversal theorem allows me to prove lines are perpendicular. You can see it in the then section. So what I have to do is show that I have perpendicular lines with parallel lines. And if I can show that, then I can show that I have the two other lines are perpendicular. Okay? So, how am I going to do that? Let's take a look. I'm going to keep my face big here. I need to somehow show, if I can, that these two lines are parallel. And if I can show they're parallel, then I can show if these are perpendicular and these are parallel, then I can use the perpendicular transversal theorem, and that would be ideal, okay? Because technically this line does go all the way through, right? It extends, okay? So, step 2, how would I prove, I want to prove that these two are parallel, okay? Well, if this angle is perpendicular, then we know that that angle is 90, and that angle is 90, so we know that right angles are congruent. So we can basically establish that we have parallel lines because their corresponding angles are congruent. Okay, we have a better definition for that, which is our theorem where we wrote earlier. It was our second theorem that we wrote down. If we have two lines that are perpendicular to the same line, then we know those two lines are parallel. So we're going to actually go ahead and write that A is parallel to B, and I'm just going to write what the theorem said. It says if two lines, right, if two lines, and this doesn't have a theorem name, so we just kind of have to write it out. If two lines are perpendicular to the same line, then they are parallel. Okay, boom, 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 and boom. That says parallel, sorry about that. Okay, so we do know these two are going to be parallel. Well, since these are parallel, I know that I can go ahead and use the transversal theorem, the perpendicular transversal theorem that states if C is perpendicular to D, then we can show that A and C are going to be related to one another. So let's go ahead and show that. Okay. So C is perpendicular to A, and oh, I wrote that down wrong. I apologize. Let's fix that real quick. I apologize. I wrote the wrong angles down when I was doing that. I'm not showing these two are parallel. I severely apologize for that. I am showing the other two lines are parallel. That would make more sense. I'm sorry. I'm just trying to show that these two lines are parallel. Okay, it works for both ones because they're still perpendicular to each other. I did the wrong one. I apologize. So C and D. Here we go. Now we're on the right track. Again, sometimes you got to rethink what you're doing. I was kind of having a brain fart there for a second. But yeah, these two lines we want to show are parallel because if these are parallel and these are perpendicular, then I know this must be perpendicular as well. Okay? And that is our perpendicular transversal theorem. And we can just write perpendicular, transversal, because that is the transversal of these two lines, which is convenient for us. And perpendicular transversal, make sure I spell it right. I just have the theorem over here. Theorem. Okay. All right. Let's see if we can do one more. Okay, we're gonna stop here. Anyways, basically we need a little bit more proof practice, I think. And, instead of me just going over them with you, I think we'll go over them in class. All right.